So I'm talking about time-traveling debuggers because everything sounds cooler with time travel. And if you're going to talk about debuggers, which is a very uncool sounding thing, you should really put a really cool adjective in front of it, like time traveling. A little bit about me. I'm a programming language enthusiast. I was the kind of person who always wanted to try new languages and then think about how they were good and how they were bad and how they were cursed. This is relevant later. I'm now building my own cursed language. I'm currently at Zoo.dev, which is a startup. We're building new CAD products. A lot of CAD kind of uses the same computational engine or kernel from the 70s. And so it cannot take advantage of extra threads or CPU caches or these really powerful cheap things called GPUs that you may have heard of before. So we're trying to build a new CAD platform that uses those things and can therefore be faster than what all the old graybeards at NASA used. I mostly work on backends. That's what I was hired as. But we try to automate a lot of the toil out of using backends. So we don't like to constantly be making small PRs like, oh, I forgot to add this one field to the spec. So we also generate APIs automatically. So I do a lot of that stuff. And like I said, I'm a bit of a programming language enthusiast, and we realize we're going to need to build our own programming language for this product. More about that soon. So as the most opinionated person about programming languages, I naturally nominated myself to help out on that front. I used to, in the way old days for React, do some front-end dev. Then I moved to Austin. I used to live in Sydney, where I was born and raised. I did iOS dev, where I met Areg, who you're going to hear from later. And he then later brought me onto Cloudflare. We worked on tunnel products together. I joined the team just a few months after Danny left the team. I guess she didn't want to work with me, and that's totally fine. I also blog. Yeah, I blog at adamchalmers.com. So we're making something called the Zoo modeling app. I'm going to show you what it does here. You can see it's loading stream. Whoop, that is really big, hey. That's a big cube. Let's change that. Here's a little live demo magic. Let's change that cube size to only 4. Still kind of too small. Let's change that to just 0.4. Yeah, that's better. So you can see here I'm editing code on the left, and I can then get this cube that's visualized on the right. And I can move it around and I can change it. This is pretty smooth. You may not know, but this is actually running in the cloud. So the Zoo modeling app, our whole business model is we make an API that runs in the cloud. We have a really powerful GPU running in the cloud, so you do not have to buy a really powerful GPU yourself. You don't have to worry about your laptop battery running out. It's all running in the cloud, and this is just a really thin client. You can modify code here. This is my programming language, KCL, kitty cat language. But a lot of people who do CAD, they don't want to have to necessarily learn code. They may not even have a coding background. So we also have a totally visual editor. You can see here I'm going to start a new sketch. I'm going to draw some lines. And you can see on the left, as I'm drawing these lines, it's actually generating the code for me. So I'm OK with this line now. I'm going to exit sketch. And I get my little 2D shape. And now I want to make it 3D. So I can click on it. You see that it actually highlights the part of the code that I'm looking at. I can go to extrude it up into the 3rd dimension. Let's extrude it. And it adds an extrude command right here to extrude it to the height I want. So there's a lot of apps that kind of have code integrated into it, but it's kind of an afterthought. This is actually purely code-driven, and then we've built a UI layer on top of it so that all your models always kind of make sense. The programmers in the audience will understand the advantage here, and hopefully the non-programmers in the audience will be able to learn it, because as they're using the UI, we naturally generate code for you. So that is the Zoo modeling app. Now, I said we're making our own language. The reason is because existing languages are not really designed for making hardware. They're designed to make software. This means they have a lot of unnecessary things you don't want, like updating variables. You're really just defining a shape. There's nothing changing. A cube is a cube. Maybe you want to change your definition of a cube, but that's not being changed at runtime. Languages have a whole heap of things you don't need, like TCP support. You don't really need if or conditionals, because you don't actually want your design to kind of turn out differently every time someone reruns it. That would be a bad feature. On the other hand, it's missing things we do need, like units of measurement. We all would like to just say, this line is 5 feet long, and have a colleague say, this line here is 2 inches long, and this colleague here from some crazy place like Australia say, no, we're using kilometers now, and have it all just seamlessly work. We'd like to do stuff like that. We'd like to have support for 3D geometry with a standard library of things like spheres. Most programming languages do not have a concept of sphere in the standard library. So the good thing is we can make our own programming language and perfectly cater to what we're trying to do. The bad thing is now you have to employ a compiler engineer, and if you don't have one, then congratulations, now you're the compiler engineer. This is what I signed up for, apparently. The V0 is what we call a tree walk interpreter, where you take the abstract syntax tree and you execute it node by node by node. This is really simple. It's a nice way to do it. The downside is it's slow, and you cannot really do good compiler errors, because by the time you discover a variable is the wrong type, it's too late. You're already in the middle of code, and you can't give as good of an error message. So the next one that I started working on is what we call a bytecode VM. I thought, wouldn't it be great if computers could naturally just understand kitty-cat language? They can't. But what if they could? Oh, I'll just design this computer that can, and I'll just simulate the computer on a real computer. Sounds dumb, very effective, actually. So the high-level language you saw is called KCL, kitty-cat language, and I designed the kitty-cat VM. I designed something called Grackle that compiles KCL into KCVM instructions. It's called Grackle because it's not very impressive. It's a bit shitty, just like a real Grackle. And I hope that one day V4 will be named like Eagle or Falcon. But right now it's just Grackle, and that's fine. It's V1. So what is a VM? What does a computer have? CPUs. CPUs have instructions, right? So my CPU, my fake computer will have instructions too. Has instructions like setting a value in memory, or copying things, or adding and subtracting numbers. But critically, it also can do API requests. I thought, man, this whole thing would be so much easier if CPUs could just natively send requests to the kitty-cat API. So I'm designing a computer that can do that, and I'm simulating it. CPUs need to store, or computers need to store data somewhere. I really hate memory. Memory is usually made of bytes, which are fine if you're trying to add 8 bits of numbers at a time, and really bad if you're trying to do anything else. We kind of hacked string support and floating point number support into bytes because it was faster than redesigning the computer from scratch. But I'm making my own fancy computer. Fuck it, my computer will actually understand what type of thing in memory is. My computer knows what a string is, and it can store a string in one byte of memory and an integer in the next byte of memory. It's fine, it doesn't have to be practical. I'm simulating it all anyway. Data gets stored in memory. Memory has addresses. I like how addresses start at 0 and they go upwards. I thought I'd keep that feature from real computers. Real computers also have a stack. I didn't really understand this when I started the project, but it's turned out to be really, really useful. Programming language people will understand why. I/O, again, it would be great if computers could naturally understand the kitty-cat API, so this one will. It doesn't have to worry about a hard disk or about coax cables or anything. It can just send HTTP requests to the kitty-cat API. So when you're trying to make a really long program, you'll often mess it up, and especially if you're building the compiler, your instinct that, oh, it's never the compiler, it must be my code. No, if the compiler is your code, you probably fucked up the compiler too. So I built a debugger for this VM because real computers have debuggers, and I would like to have a debugger for mine too. I thought, again, it should be a time-traveling debugger, right? Because the way that generally executing a program works is it updates memory. Each instruction reads from memory, then you maybe change the value, and then you maybe rewrite it back to memory. But of course, by the time you realize something's gone wrong, memory has already been changed. So when I'm simulating this CPU, I was doing it the idiot way of saying, okay, read an instruction, change memory, read another instruction, change memory again. And this makes it hard to figure out, hey, why is that memory even like that in the first place? So instead, there's a special execution mode called run with time travel, where it doesn't update memory. It saves a snapshot of memory each time. And then if something goes wrong, you have all those snapshots of memory. Even if something goes right, you still have all the snapshots of memory to look back at. So here's an example. On the left, you can see a program that KCVM is loading. You can see the instruction is set primitive, set address 0 to a list header. That's a special kind of data structure. And set address 1 to the uint1. And you can see as we step through using, you can use arrow keys, or if I switch over to my normal dominant hand, I can use Vim keys because I'm a nerd like that. And you can see it actually changing memory. Now, some of the events, some of the instructions, like copying, I'd like to know more detail about what's going on. So when you execute an instruction, the VM can also emit an event. You can see events down here in the, does my cursor show up there? Yeah, nice. So it emits events like reading a value from address 2, writing it to address 5. And I work better in color, so I thought, okay, the events should color in the address they're using so you can clearly associate the memory addresses with the events that are going on. it keeps going, and then I hit a point recently where my programs were actually more than 19 bytes of memory long. That was a big milestone. But then I thought, oh shit, now I have to worry about like overflowing. This is why I stopped doing front end. I don't want to learn CSS, whatever. It's fine. Now you can press tab and switch between the panes, and you can scroll down memory too. Wow, it's almost like it's a web app, but it's just running in the terminal, so I didn't have to learn JavaScript again. Yeah, that's basically it. You can see the stack is getting pushed and popped and everything. I should probably make the stack scrollable as well. You can see that some stuff is going on the stack too, but I haven't done it yet. I didn't time this and I didn't practice it, so I'm probably over time, and I'm sorry about that. I'm going to wrap this up. There's, yeah, it's all on GitHub. The entire modeling app you saw is open source. The VM you saw is open source. All the language tooling is open source. We make money from our API, so that's closed source. Stay in touch. I write about programming and stuff on my website. You can get my contact details there. I have stickers. Please come get KittyCAD stickers if you want some. And it's all open source. We're also hiring, so if you're a senior front-end dev, please talk to me. Thanks, everyone.